Welcome, problem solvers. Today, let's dive into an intriguing problem revolving around structured bindings in C++. The issue at hand is that structured bindings currently do not support empty decomposable types. This can be quite limiting, as shown by the error that arises when attempting to use structured bindings with an empty tuple. Now, let's explore how this problem can be tackled with a clever solution. In the proposed solution, the introduction of packs and structured bindings opens up new possibilities for handling empty cases. Specifically, the implementation of std. Apply can be significantly simplified by allowing empty packs. The key snippet of code that demonstrates this concept involves setting up a template function for std. Apply, using structured bindings to unpack elements from a tuple. This streamlined approach not only enhances the readability of the code, but also showcases the flexibility that empty packs bring to generic programming. By embracing empty packs and structured bindings, a world of innovative solutions and cleaner code awaits. In conclusion, the introduction of empty packs and structured bindings represents a significant advancement in C++ programming. By enabling the handling of empty cases, developers can streamline their code and tackle complex scenarios with ease. So, remember to embrace the power of structured bindings and empty packs in your C++ projects. Thanks for watching, and don't forget to like, subscribe, and leave a witty comment below. Happy coding!